KNIME, which stands for Constant Information Miner, is an open-source platform designed for data analytics, reporting, and integration. It was developed by a team of software engineers at the University of Constanz, Germany. KNIME is widely recognized for its intuitive, modular, and flexible approach to data processing, enabling users to visually create data workflows without extensive programming knowledge. Key features. 1. Visual Workflow Editor. KNIME's Visual Workflow Editor is one of its most appealing features. It allows users to construct data workflows by simply dragging and dropping nodes onto a canvas. Each node represents a different step in the data analysis process, such as data extraction, transformation, modeling, or visualization. This graphical interface makes it accessible to users of varying technical expertise and simplifies the process of building complex data pipelines. 2. Extensive Node Library. The platform offers an extensive library of over 2,000 nodes for various data manipulation tasks. These include nodes for data cleaning, transformation, machine learning, text processing, image processing, and more. This extensive collection allows users to address a wide range of data analysis challenges without needing to write custom code. 3. Integration Capabilities. KNIME excels in its ability to integrate with various data sources and external tools. It supports connections to databases, such as SQL, NoSQL, file formats, CSV, Excel, JSON, and big data platforms, Hadoop, Spark. Additionally, KNIME can interface with other software such as R, Python, and Weka, allowing users to leverage additional analytical capabilities and custom scripts within their workflows. 4. Advanced Analytics and Machine Learning. The platform supports advanced analytics and machine learning through a wide range of pre-built algorithms and models. Users can easily implement supervised and unsupervised learning techniques, time series analysis, and deep learning models. KNIME's integration with Python and R also allows users to utilize external machine learning libraries, such as TensorFlow and scikit-learn. 5. Collaborative Environment. KNIME promotes collaboration and sharing among team members. The KNIME server facilitates workflow sharing, version control, and automation, enabling teams to work together on projects seamlessly. It also supports deployment of workflows and predictive models into production environments, ensuring that analytical insights can be operationalized effectively. 6. Extensibility. As an open-source platform, KNIME is highly extensible. The KNIME community actively contributes to the development of new nodes and extensions, which can be easily integrated into existing workflows. Users can also develop their own custom nodes and plugins to meet specific needs, ensuring that KNIME can evolve with the changing demands of data science. Applications. KNIME is used across various sectors including finance, healthcare, retail, and manufacturing. In finance, it assists in credit risk modeling, fraud detection, and investment analysis. Healthcare professionals use KNIME for patient data analysis, disease prediction, and clinical research. Retailers leverage KNIME for customer segmentation, market basket analysis, and supply chain optimization. In manufacturing, it is used for predictive maintenance, quality control, and process optimization. Conclusion. KNIME is a versatile and powerful tool for data analytics and machine learning. Its user-friendly visual interface, extensive node library, and robust integration capabilities make it a preferred choice for many data professionals. By facilitating the entire data analysis process, from data extraction to model deployment, KNIME empowers organizations to derive actionable insights and drive data-driven decision-making.